Hello and welcome to this SimLogic webinar, Reduce Downtime and Improve OEE. My name is Claire Healy and I'm your facilitator for today's webinar. Today's webinar will be recorded, so we will ensure the recording is sent out to you in a few days. Just a brief note on housekeeping. So we want to make this webinar as interactive as possible. So if you do have any questions during the webinar, please do use the questions panel on the right hand side of the screen, and we will aim to address these at the end of the webinar. If we do run out of time, we will answer your questions via email. So now I'd like to hand you over to today's host, Fraser Thompson, the Business Development Manager at SimLogic. Over to you, Fraser.
Thanks very much, Claire. Hello everybody, thanks for joining the webinar. As Claire mentioned, I am officially the Business Development Manager, but you can see me more of an MES consultant. I get involved with a lot of projects with customers in the UK and Ireland and further overseas. Now with relation to OEE, quality management systems, electronic batch records, everything kind of falls within the MES spectrum really. So if you do have any questions, again, as Claire mentioned, pop them in the sidebar, and if we don't get time at the end of today's session, we'll do our best to answer them over email in the coming days. That's a little bit about me. Now a little bit about SimLogic, just to kind of set the scene. We are a UK-based company over in West Yorkshire. That's our office there on the left-hand side in the World Heritage Centre Salts Mill in West Yorkshire. It's a lovely part of the world, and our business is primarily focused around MES or MOM software applications. But as well as just the software applications, we're also focused on the integration of those software systems both to the shop floor in terms of the control systems and SCADA layer, but also upwards into the business systems arena, where we would be talking about integrating with ERP systems and so on. But the software is only really part of the picture really. You need to know a little bit about the technology, about barcode scanners, RFID, PLCs, as we said, but also about what you intend to do with all of this data once you capture it. MES and MOM systems will capture a lot of data. They will instruct operators how to perform various different operations, but unless you have an understanding of operational excellence or lean manufacturing practices, you really need to be able to use that data in the right way to be able to drive improvements. So that's kind of what we set out to do as a company. So just to set the scene a little bit for today's presentation, I've got a quote on the screen which I'll just read out. Measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. And if you can't control it, you can't improve it. And I'm sure many of you would have heard, if not that exact quote, something very similar. And it's very true in all aspects of life, whether we are baking a cake and we're trying to guess at the ingredients, and what we end up with is an omelette instead of a cake, or whether it comes to, as we're talking about manufacturing data. If we don't understand, if we can't measure, then how can we expect to control and improve our processes? So we'll keep that phrase in mind as we go through today's webinar. It's fairly key. So for those of you that are familiar, overall equipment effectiveness is what OEE stands for, not efficiency. What is efficient is not necessarily effective. And again, that's another key thing to remember. And if manufacturers are looking to improve, then OEE is a very key metric for them. If you're looking to achieve goals like increasing your capacity, decreasing your time to produce, your on time in full, increasing the return on your assets, whether they be 40-year-old assets that are perhaps coming to the end of their useful life, but you still need to get a turn out of them, or whether it's a brand new shiny stainless steel case packer that you've just purchased, you still need to get a return on that purchase that you've just made. You need to ensure that your investment is returning. Reducing operating costs, so again, maybe making the same amount of products with less or reduced operating costs, less energy costs, for example, or looking at making cuts into the conversion cost per unit, the amount of money it takes you to convert raw materials into finished goods. Better manage our capital, and for those of us with shareholders, what it's all about again is increasing their return. So OEE, as it says there, is an effective methodology to help us improve our manufacturing processes and measure the true plant productivity. If you're not using it, I suggest that you do, and again we can help you along with those journeys. So traditionally, how do people do OEE? In a manufacturing context, I would say probably if it's not OEE that's measuring, but some kind of general efficiency metric, I would suggest that probably 70 to 75% of people are still doing this as a manual exercise. And by manual exercise, we mean the operators on the shop floor have a paper-based form to fill in, so whenever they experience some downtime events, they are asked to record the duration and the reason of those events on a piece of paper. At the end of the day, at the end of the shift, perhaps all of these bits of paper are collected by somebody and they take them away to the back office, and then they spend the rest of the shift manually typing that information into Excel, and then somebody prints out a chart out of that Excel and they stick it on a wall somewhere on the shop floor for everybody to see. Maybe that's done at the end of the day, maybe that's done at the end of the week or the shift, but it's often retrospective. And what tends to happen is you will spend most of your time gathering and questioning the data rather than actually getting into sort of deep analysis and looking at how you can use that data to drive improvements. You end up quite often spending a lot of your time in meetings where you're discussing whether the information you're being presented with is fact or opinion. And again, nobody wants to make decisions based on opinion. You want more facts. And the line at the bottom there is something I heard recently from one of our clients is we know that it's wrong, but we use it anyway. And that really is a little bit of a striking moment, if you like, whereby what exactly is the reason why you are doing this? You're obviously not engaged with the improvement process. You're just there to put a tick in the box, which is obviously quite concerning. So we want to get away from that. We want to be starting to use this quite important manufacturing metric to help us drive our productivity. The drawbacks to doing things manually, again, we've discussed kind of that all of our time will be spent looking at the numbers, questioning things. What we'll quite often end up with is, after a year, what we've got is a pile of data in folders, and that information is just locked away in a cupboard somewhere for reference if we need it, should we need it in the future. The information is provided to us probably too late. If we're gathering that information at the end of the day and the end of the week and we're not looking at it till the end of the week or the next week, how are we going to make a difference to the current shift that's running right now that might be experiencing performance issues if we're not going to know that they've experienced performance issues till this time next week? Next quote, top right, if it's not accurate, it might as well not exist. I'm a true believer in that as a statement, although some would say that the benefit of a manual OEE recording system is to engage the operators in the process so that they understand the metric, they understand the calculation, they're involved in how it's put together, and that is true. It's very important. That's almost the most important factor in measuring OEE successfully, is to get engagement across all levels of the business as to what the KPI is, what it can be used for, and what it's telling you. But essentially, if you're using this metric and you're fabricating the results, again, you're using those results to make business decisions, then certain questions need to be asked. And one of the most important things is the intention of the picture in the bottom right-hand side of the slide there is to say that the information is not necessarily right in front of your face. It needs to, as you walk on the shop floor, the information needs to hit you in the face. You need to understand exactly where you are to plan today, what the current performance levels are and what you can do about it. And if it's not there and it's not obvious, not in your face, it's going to take you longer to react to that. So there's some of the drawbacks that we tend to see with manual data recording systems. But when we think about it, If we want to automate this process, it's not actually that hard. If you think about OEEs made up of 3 fundamental blocks: availability, performance and quality, it's actually quite simple to measure automatically and accurately. In its most simple guise, availability essentially is the line running, yes or no? You know, it's from an engineering or software point of view, it's a Boolean answer. It's a 1 or a 0, it's on or it's off. Is the line running, yes or no? Performance, if the line is running, how fast is the line running? And all of this information you can get just from one single data point. So if you were to put a single sensor on the bottleneck machine of your production line, and from that sensor you could determine if no product has passed this sensor in a defined number of seconds, then we must be experiencing an availability loss. The line must be down, we're not producing. Then that's great. If the line is running, if we've seen a certain number of units pass the sensor in a certain period of time, then all we need to do is understand how fast the line is running. We need to do a simple calculation to say how many units went past this sensor in the last minute and turn that into a rate calculation. So it is quite simple just to get a lot of information that you need to generate a accurate and real-time OEE metric from just a single data point. And that is both timely, it's accurate. You know, if the line was down for 4 minutes and 32 seconds, you will know that the line was down for 4 minutes and 32 seconds. Not necessarily that the line might have been down for 5 minutes, or we might not have noticed it at all. And some of the typical gains you will get if you're able to do this quite simply in an automated fashion is firstly to look at very short stops. So stops that might be anywhere between sort of 5 seconds to 3 to 5 minutes. And again, if we go back to the principle of manual data collection, and we think about the kind of information you might see on your manual OEE sheets, I would be very surprised if the information is not in blocks of 5 minutes, for example, and anything less than 5 minutes doesn't necessarily get noticed. One of our clients recently said that they were stood on the shop floor with their back to the line. They hadn't even noticed that the line had stopped for around 20 seconds before they turned around and saw that it had stopped. And as you can imagine, you know, we're only human. It's very easy to miss that kind of information, but it's also very important that we have exposure to that information because it could be one of our top losses. So short stops that are sort of less than 5 minutes are a key or an easy win that you can achieve by measuring OEE in real time accurately. The next area to look is speed issues or performance losses. Now, depending which school of thought you belong to, you may treat performance losses slightly differently. Some people would say performance losses are downtime events that are not related to the equipment being at fault. So it might be that we've had to change a label reel on a labeler, for example. That's no fault of the labeler. It's just a fact of life. It's a performance issue that we might see. Now, I would perhaps go one step further and say, for clarity, let's call that an availability loss. And what we will do with performance losses is we'll just consider performance to be speed-related issues, and it keeps the boundaries quite clear. And if you're very early on in your OEE journey, it's quite good to keep things simple and understandable in that respect. So by measuring the performance in real-time accurately through a sensor, you're able to determine the speed of the line, you know, every 15, 30 seconds to 1 minute. And what the chart in front of us there is showing is we've got an effective or a required theoretical run rate for our machine is the green line, a target rate for this job is the red line. And when we do a product changeover, for example, that's what's happened here at 10:30, is we're increasing the speed of the line, the theoretical speed of the line, from around 220 units a minute to around 280 units a minute. And what you can very quickly see there is that although we are now running a product that can theoretically run faster, we haven't altered the speed of the line itself. So straight away, all of this here is a lost opportunity to be making good saleable products in the same amount of time. And again, if we're running a manual system, it's very hard to pick that up because during these times here, for example, between 11 and 12, the perception will be that the line is running. It's very hard to determine the difference between 180 and 220 units per minute just with the naked eye. So that's a very easy win that, again, that you can get from that. Now, if we consider adding maybe a couple more data points to our line, if we consider that now for our line we're not just using one in-feed to one machine, but perhaps we've got one in-feed sensor per machine on the line, you're able to then look at things like the flow of product through the process, or line balancing. So in this case, again, another real-world example where a line starts with a profile or flow that's very linear. When it's running, it runs very steady at a constant speed. There's a couple of issues where we have some downtime, as you'll see here. But when we get up to running, we're running at steady state, and it's nice and frequent. And as the material flows through the line and we get to what is the bottleneck machine on the line here, 5 machines later, we can see that the flow is so much more irregular. We've got overspeeds, we've got underspeeds, we've got overspeeds that cause short stops. We're out of control at that point, and being out of control is not good for automated equipment. Automated equipment like flow of materials to be constant and regular. They don't like to be presented with materials in different speeds at random times because it causes short stops, it causes problems. And again, very easy to get this kind of information from an automated system. So just to show you a very quick example, we've got a new product which we're releasing called OEE Express, and the intention of OEE Express is that it's able to capture OEE in its very simplistic fashion using just a single data point, as discussed, and from that single data point we're able to generate a lot of useful information for both the operator and the operations team in general. So what we've got here is a very quick video of a demonstration system here. What you can't quite see is just behind this wheel is a single sensor, and that single sensor, as we said earlier, is detecting if the line, in case this wheel in this case, is running, and if it is running, how fast it is running. The operators will have an input screen that will look something like this, that will indicate their current production, their OEE metrics, their current line speed, and anything else that happens during the day. So for example, if the line does stop for whatever reason, it stops for a reasonable period of time, that we want to present that information to the operator. We'll say, actually, yeah, your line is down, tell me why. And by drawing the line there, by saying we're going to get automatic data that says this is when the line stopped and this is exactly how long it stopped for, and if it's significant enough, we're going to ask for context from the operators. That then builds in the engagement that people sometimes think is the piece that you would miss from an automated system. So we're going to ask the operators maybe 10 to 15 times a day or a shift to enter some information. So when the line stops, screen flashes red, the operators are asked to enter some information onto the system to say, tell me exactly why you think the line stopped for 3 minutes and 22 seconds in this instance. And then behind that there's a whole suite of reports that you can use to analyse the data and look to drive your improvement programs. So hopefully that's a very quick example of how simple it can be in reality. But simple is not necessarily always going to be good enough for you. It will be good enough for you to get to a certain level, but then you're going to need to consider, have you actually got enough data? And this is the point where we can ask ourselves the question, or we can make the statement that correlation is not necessarily causation. Just because two things seem to be linked doesn't necessarily mean that one causes the other. A good example of that here is a quick chart that says, okay, if we're looking at global warming, what we want to do is we want to reduce the average global temperatures. We don't want to see the global average temperatures rise too much because the polar ice caps will melt and we'll all drown in seawater. So what can we think might be an impact, or what might be an impacting factor on that, or a correlating factor? And here what this chart is showing us is that actually if we want to reduce the global average temperature, what we should do is increase the number of pirates that are active in the seas. It's almost a linear relationship. It's quite obvious from that data set that one matches the other. But we know that that's not necessarily true. We haven't got enough of a sample set. We haven't got enough data points behind this to make that statement. And hopefully all of us would know that that is an untrue statement, that the number of pirates does not necessarily affect the global average temperature. And the same is true in manufacturing. So other things can have an impact. What shift is running. If maybe it is a skills issue that's causing certain amounts of downtime, and one shift operates a machinery different from another. Maybe it's product related. It's to do with the ambient temperature in the production facility. Maybe it's to do with the supplier of materials. Maybe if you've got issues with your case packer, you're experiencing lots of jams with your case packer. Maybe it's because of the coefficient of friction of your cardboard boxes. Maybe it's because the machine settings are set up differently, different times of day or for different products. Maybe different products at different weights run differently. Maybe just different product types have different coloured labels on, or shiny surfaces as opposed to dull surface, and that affects the quality. Maybe the time of day, maybe the quality of ingredients. There could be numerous factors that also impact what is happening. So beyond the very easy quick wins, you need to start to look a little bit deeper. And a good example of that is here. So I've got a quick Pareto chart here that shows us where on our production line we experience most of our downtime issues. And this is telling me that most problematic machine is the labeler. And so if that's your data set, you might look at that and say, okay, I've definitely got an issue with my labeler. What I'm going to do next time we've got a maintenance window is I'm going to send one of our reliability technicians down to the line. I'm going to get them to strip down the labeler, refit it, change the reels, and hope that the problem goes away. But if we were able to put more data to it, maybe we could make a slightly different decision. So for example, if we asked the operators then to give me a little bit of context as to what was happening with this labeler, what were the top issues with just that labeler, we might get a different picture. So here we've got, again, top reason, label jams followed by no labels, side cover open, etc., etc. Maybe we get that from the machine, maybe we get that from the operators. It's an example of another subset of data. So that's maybe pointing us in a different direction. So maybe what I'd do in that case is I would go and change the label reel, or have a look, for example, if the splicing of the label reels was being done correctly. But again, we can still get more information from there to make a better decision. So if we're able to tie that in with, for example, the product that we're running, is there any kind of direct correlation with label jams on the labeler when we run a particular type of product? And here it looks like we do get some more issues with certain products than we do with others, but there's nothing jumping at us there. Maybe we look at, say, whereabouts the jam is occurring. Is it occurring at the drum? Is it the infeed? Is it because of adherence or adhesive issues? Perhaps it's a difference between the shifts. Do I get more label jams on one shift than the other, or do I get more label jams when I use bottles from a different supplier? By pulling in all of these different data sources, we can get information in context to help us make some better business decisions. If this pie chart here was slightly different, maybe 75% of our label jams occurred from bottles from one supplier, that might make you think completely differently. So rather than sending an engineer to look at the labeler in detail, what we actually might do is get somebody from procurement involved and say, look, these bottles, they might be cheaper, but actually they're 75% more difficult to run and they cause us all of these issues on the labeler. Please, can we get bottles from our other supplier? So we can use the information to make better decisions. So if we go back to the OEE calculation, some of you might remember earlier that I said OEE, we kind of forget about the quality. So here's a theory for you. If we're doing OEE on kind of packing or production lines, we shouldn't really need to include quality in the metric. It can confuse things. According to the 6 big losses, if you're familiar with OEE, quality should include things like startup rejects or production rejects. But it's almost impossible to capture these things accurately and automatically. Again, going back to the statement earlier, if it's not accurate, it might as well not exist. I'm going to bear that in mind when we consider quality. And there are various reasons for that. Here's just a couple of examples. So my process continues to run, but packing is experiencing some kind of availability losses, some kind of machinery down. And everything at that point is going to scrap. So I'm just going to open up some kind of guard and all of my bread buns or all of my glass bottles are just going to go to scrap at that point. So you can ask yourself the question, is that availability, or is it quality, or is it both, or is it availability with scrap but not quality? Whichever way we decide to go with it, we shouldn't double count it, because we would be adversely impacting our OEE figure. But we definitely need to know that the machinery was down, and we definitely still need to know how much product we've had to scrap. But it don't necessarily fit nicely into an OEE calculation. Second instance, operator walks past the line, he takes 3 cans off. It's very hard to capture that manually, unless the operator is very honest and he goes and writes down the fact that he took 3 cans off at 10:52, and this was the reason why. But who's to say that he won't put those 3 bottles back on at a different point in the line from where he took them off? So at that point, we could end up with a different kind of scenario, as it says in the bottom statement there. So bottles are taken from downstream, reworked, and placed back upstream. And in that instance, if we're trying to count our rejects, we'll end up with a scenario where we had 1 in and 4 out. So we've got 400% quality in that instance. And that's reporting that kind of information is not good for anybody. If you start to report 400% of anything, people are going to look at that data, they're going to start to question it, they're going to start to not believe it, and the value of all the other good data that you have captured is then lost straight away. But that's not to say that quality is not important. It definitely is. And if you are experiencing quality loss, there are better ways, better tools to look at, to start using to capture this information. So if you want to explore this area a little bit further, please have a look at one of our other webinars that explore the area of quality management, electronic quality management, and SPC for kind of operationally focused quality management. It's another very important topic, but I'm trying to draw a line between OEE and quality as being something completely separate. So if we consider the last fact on my first slide, that the information is not necessarily in your face. A lot of the power of real-time information is that you can present the data in real time and make it nice and obvious to people. And a good kind of real-world example of this that I like to use is the little smiley face speed signs, I'll call them, that you see there in the picture on the right-hand side. Don't ever underestimate the power of the smiley face. If I drive past one of these signs, I want to make it smile. I don't want to see a sad face. I want to get my speed correct, so I get that warm fuzzy feeling inside from seeing the smiley face. And at this point, there's no punishment. There's no repercussions from the fact that, okay, I was doing 33 and I got a sad face. I just got a sad face. I didn't receive a fine. I didn't get 3 points on my driving license. But it has had the desired effect that I've wanted to slow down to get that smiley face. And the same can be said for presenting your OEE information. So it's not a tool, it's not a metric to go about beating people up to say, why aren't you performing as well as you should be? But if you can present that information in an informative manner, in an obvious way, it can often have a very, very quick impact. And the impact of this particular sign in this case was that it resulted in the number of speeders being reduced by 53%. And quite often you can see a 2 to 5% jump in your performance just by presenting information to people that need it in real time in an easy to understand fashion. It's red, it's green, it's amber, and we're ahead of target, we're behind of target. Very, very obvious, very, very simple things to do. So how are we going to go about doing this? So we're going from a manual system. We want to think about going towards an automated system. It's going to require some kind of investment. What you're going to need to do is you're going to need to build a good business case around it. And very often, a simple business case to do would just be to look at what a 1 or 2% increase in your efficiency or in your OEE calculation would do for you per year. It's going to do one of two things. It's going to mean that you can either produce more and sell more, which is great, or it's going to mean that you can produce the same amount in slightly less time. You need to reduce your overtime, for example, to do that. If you've got all that information, why don't you try doing a quick calculation? I've got an example on the next slide that can run you through how easy it is to do that. This is a semi-real world example. I've taken some real world numbers and I've massaged them slightly to make them round and taken off all customer names, etc. But here's a good example where I'm going to run 40,000 units or 40 million units in a year. It's going to cost me 15 million in costs for the raw materials. Labour is going to cost me 1.2 million, and all the other production costs, the gas, the lighting, the office cost, the PCs, etc. It's going to cost me 6 million. So I can work out a cost per my unit. I know my current efficiency is, say, 40%, so I've got a gap of 60, and all I want to do is I want to make a 2% dent in that. And with that 2% dent, we can produce more. It's going to cost us more if we're producing more because we're going to consume more raw materials, but we're not going to necessarily consume more production labour. All the fixed costs are going to stay fixed. So these additional units that we make, we're going to make more profitably. And very quickly you can see that the returns very quickly add up for what is a very small increase in our OEE. So if you're able to do these calculations correctly and base it on your real data, it's very easy to justify what essentially is quite a small investment for the returns that are possible. So that kind of wraps up today's webinar. Just to touch on what we offer as a company again. So SimLogic, we're about the operational technology, the integration with the shop floor, the sensors, the PLCs, the barcode scanners. We're about the manufacturing operations management software, the OEE software, but we're also about how those systems are supported and how you use that data to drive your operational excellence. So if you do have any needs or you'd like to discuss further any of the topics that we've discussed in today's webinar, please give us a call. You can see how we've helped customers such as those on the screen in front of you. And at that point, I'll very briefly introduce our customer conference, which we're holding on the 21st of June. For those of you that are interested in what we do as a company, looking at big data in manufacturing, you're looking at Industry 4.0 and you're wanting to understand all the buzzwords and what can be done about it, then please give us a call or visit us on the website and have a look at this, and you feel free to register. And at that point I'll hand you back over to Claire just to wrap things up.
Brilliant, thanks Fraser. That was a really informative presentation. You gave some great tips on the tools that can be used to measure and improve OEE of manufacturing processes. If you have submitted any questions in the control panel, we will respond to them via email. And just to remind you that we will be sending out the recorded version of the webinar over the next few days. So do feel free to pass on to colleagues and re-watch as you see fit. If you'd like to discuss OEE in more detail with one of our MOM experts, please email inquiries@simlogic.co.uk or give us a call on 01274 599 955. And for further information about SimLogic solutions, please visit www.simlogic.co.uk/MOM solutions. I would like to thank you for joining us today, and we hope you enjoyed the webinar. Thank you.